Welcome back to the video lecture series on engineering mechanics. Myself, Dr. P. Pramod Kumar, Associate Professor in the Department of Mechanical Engineering, MLR Institute of Technology. In this video, we are going to study the centroid of triangle as part of centroid and centroid gravity unit. The derivation of formula for the centroid of triangle is being derived in this video lecture. Consider a right angle triangle of base B and height h as shown in figure. The area of the triangle is half into B into h. Let xy be the reference axis for locating the centroid. Here I am taking the entire triangle on the right side of the coordinates. The left and bottom corner is origin. Consider a small strip, rectangular strip of width dy at a distance of y from x axis as shown in figure. The strip is having width dy and it is at a height of y from x axis. The area of the small strip is dA. I am considering it as a rectangular strip, neglecting the slant distance because the strip is smallest possible strip. For that smallest possible strip, the slant edge, addition of slant edge is negligible. That's why considering it as a rectangular strip, b dash into dy. See, in the case of a rectangle, we have taken a strip which is equal to the width of the rectangle itself. But here, as we move upwards from base to apex, the base or the width of the triangle will reduce. At the height of y, the base is b dash, which is not equal to b. Here in this derivation, the key point is to find the value of b dash first. Now, to find the b dash value, I am taking the same triangle and I am considering the similar triangles in this. The ABC is the given triangle and DE is the line which is representing the strip. In this, ABC and ABC and CDE are the similar triangles. By using the properties of the similar triangles, we are going to find B dash and we will substitute the b dash value back into the equation. So, from the similar triangles ABC and DEC, the property of the similar triangles is ratio of bases is equal to ratio of heights. This is the property of similar triangles, or otherwise we can use in another way, the base by height is a constant for similar triangles. So, let us take the bases, ratio of bases. B dash is the base of small triangle DEC and B is the base of big triangle ABC. Now, ratio of bases B dash by B is equal to H minus Y, height of the small triangle. This is H minus Y. The total height is h and DE line is at a distance of y. So, the height CD of the small triangle is h minus y divided by total height or height of the big triangle ABC. From this expression, we can calculate B dash. B dash is equal to B by h into h minus y. Let us check the expression whether it is giving correct value or not. We know two values of b dash, that is at base of the triangle, that means at y equal to 0, the value is b, and the triangle base is reducing gradually and it is becoming 0 at C. Now at y equal to 0, the base value or base is B. See, now substitute y equal to 0 in this equation. If we substitute y equal to 0, the B dash expression is B dash is equal to B by H into H. B dash is equal to B. And at y equal to H, that means at the peak point or highest point, y is equal to H. Y is the distance from base. So at the highest point, y is equal to H. At that place, B dash is equal to 0 or there is no base. The base is reducing and it becomes 0. Now substitute its value at y equal to H. At y equal to H, B dash is equal to B by H into H minus H. It is 0. B dash is equal to 0. Now, after finding the B dash, let us move to derive the x bar and y bar for the triangle. Now substitute B dash in the area of the strip dA. B dash dy is the area of the strip. Substitute B dash value, B by H into H minus y into dy. Now ay bar is equal to integral y dA. Ay bar is equal to integral 0 to H. See here, there are so many strips which are placed from base to total height C in the decreasing order. In the decreasing of decrement of bases. So 0 to H is the limit. Y is the distance of the strip from base, and B by H into H minus y into dy. It is area dA. Now ay bar is equal to B by H into hy minus y square dy. B by H into hy integration is hy square by 2. Y square integration is y cube by 3. Now substitute upper and lower limits. The upper limit is H, lower limit 0. Ay bar is equal to B by H into H cube by 2 after substituting H in the y, and H cube by 3. And if you substitute lower limit, all the terms becomes 0, which is not shown here. B by H into 3H cube minus 2H cube by 6. LCM is taken. So 3H cube minus 2H cube by 6, which is nothing but BH into H cube by 6, which is equal to BH square by 6. This is a y bar. Now calculate y bar. Y bar is equal to BH square by 6a, the area of the triangle. The area of the triangle is given by half into B into H, half into base into height. So from this, B is cancelled, 1 H is cancelled in the numerator, and 6 is cancelled out by 2 by in value 3. Y bar is equal to H by 3. The centroid of triangle always lies at a height of H by 3 from base. For this triangle, the x bar, see, if we consider in a triangle, if we consider right angle triangle, if consider this as base, this will become height. Or if you consider this edge as base, this will become height. So one formula is sufficient for right angle triangle, that is, the centroid always lies at 1/3 of height from the base. So if you consider this as base, it is at a height of H by 3, and if you consider this as height, which is equal to B, the distance is B by 3. So the coordinates for centroid of a triangle or x bar y bar is equal to B by 3, H by 3. In this derivation, in this video, we have found the first moment of area, that is centroid for triangle. The formulas used are ax bar is equal to integral x dA and ay bar is equal to integral y dA. The coordinates found for the triangle are x bar equal to b by 3 and y bar is equal to h by 3. Thank you.